Okay, so just now we discussed about the RAM. Now we are going to discuss about the virtual memory. The virtual memory is in Windows it is known as the virtual memory, and in Linux it is known as the swap memory. Okay. Now we are considering virtual memory for the performance, for the faster IO activity. Okay, I will show you the RAM consists of LRU and MRU. LRU and MRU needs to receive transaction, mode to receive transaction. Okay. Now, say for example, we have ordered a server which has a 2 GB of RAM. We have ordered one server which has a 2 GB of RAM, 40 GB or 200 GB of hard disk. Okay, and it has 1 or 2 processors. Now, when we order, say it can accommodate 30 to 35 users easily. Right? Now, day by day when the business grows, the size of the database will also grow. And there is a lot of users will also increase, will be connecting to this server. The processing number of transactions will also increase. The processing, there is more processing, there is a lot of load on the server. Right. To overcome this, either you have an option to increase the RAM from 2 GB to 4 GB or 8 GB or up to 16 GB, 32 GB or 64 GB. How much you would like to spend? Okay, depending upon your budget. The other way to enhance the performance is virtual memory. Right. How do we do that? At the time of Linux installation, you create a separate partition on the hard disk. Okay, and in that hard disk, all the least recently used transactions will be moved to this category. Okay. I have explained this in this diagram. Okay, so this is the RAM that you consider, and always MIU demands more space. Okay, so the LRU has to switch to the swap area. What is this? This is the hard disk. I have 40 GB hard disk. I have given the 6 GB, which is double the size of the RAM. 6 GB in a swap area, swap memory. So all these needs which can be used, or those transactions that are not important, okay, will be used to this area, and you have a more space for the new transactions to accommodate. Alright. So always at the time of installation, give the swap area double the size of the RAM, or it could be the triple the size of the RAM. If you have more space, for example 100 GB, giving 9 GB or 10 GB to the swap space doesn't make a difference. Your mind will be peaceful and you will have a good performance. Okay? The only option left here, for example, if you are seeing that even after increasing the swap space to 6 GB or 10 GB, you are experiencing slow performance, then you can increase the swap memory. Okay? Also, you can add another RAM component as a polling. Just like this. So now we are talking about processor. The processor will apply logic. It will compute. It is the brain of your computer. Okay. Now the processor's capacity is gauged, is measured in the amount of data that it can carry in one cycle. Okay, the processor speed volume is measured, the measurement is done, the amount of data that it can carry in one given cycle. Alright. Now we have different denominations, as you can see, different categories. Okay. Like we have 32-bit processor, 64-bit processor, and a spark. Alright. Now this means 32-bit is also known as x86 processor. Okay, this is given, the name is given by the manufacturer. For example, we have Intel, AMD, okay, Xeon processor, okay, and the various types of processors. So it's nothing but the amount of data that it can carry. So the data which is will be in the form of bits. Okay, so 8 bits is equal to 1 byte. So that means in one cycle it can carry 4 bytes of data. And here, this one, it can carry 8 bytes of data in one cycle. Right. Now, Spark is a more advanced technology, okay, advanced technology processor, only available with a Sun Microsystems, okay, is a company. Now, this company is acquired by Oracle Corporation. Now, this processor is only compatible with the Solaris operating system. You cannot use any other operating system with this kind of processor. Right? Now, let's see. Now, how would you check your configuration on your laptop? Right click on my computer, go to properties, and it will tell you the what kind of architecture. The same way on Linux you have a command called uname-r. Okay, there is a command called uname-a, right? Which you can check what kind of architecture that your server has. Now this is the basic prerequisites. These are all what we are doing in the requirements for the Oracle database installation. You need to check how much RAM an existing server has, or if it is a new server, we have to how much RAM we are going to order, and what is the architecture that we are going to use it. Is it going to be 32-bit? Is it going to be a 64-bit? Or is it going to be 5? And depending upon the hardware architecture, we are going to order the operating system, and you are going to order the database software. Right? Now, this means that on a 64-bit processor, you can run the operating system which is 32-bit as well as the 64-bit. The same case with the database. 32-bit as well as the 64-bit. But for the 32-bit architecture, you cannot install the 64-bit operating system. Neither you can install the 64-bit Oracle database. Right? Please like this. Okay, now we are talking about hard disk. Okay, the hard disk is measured with the way it's scale, the way it speaks, rotates. Okay, whenever you purchase a hard disk, okay, you will see how much RPM, okay, it can rotate. RPM is rotation per minute. RPM means rotation per minute. Okay, so you'll see on the hard disk, the Seagate company hard disk will have the RPM from 7,400 to 8,400, something like that. Okay, so a hard disk is considered as a permanent storage device. It's a permanent storage device where our data resides. Okay, and when the hard disk is new, okay, it is called a raw device. Called a raw device. Raw, R-A-W. Raw device. Right? Now there are different types of hard disk. IDE, SATA, PATA, SCSI, NAS, SD. Okay? Now, you will see each of them in the storage technology. Okay, now we'll study about this. So when you format a hard disk, and how do we format the hard disk? Exactly. So when you install an operating system, the first thing that you will do is formatting. Formatting creates tracks and sectors. Formatting creates tracks and sectors, as you saw a diagram about. See here? So these are the tracks. The round circles are tracks, and this rectangular things are known as the sectors. And this is a more clear picture that you can see. Okay? So this is all the tracks, and these are the sectors. Now, each sector is the one sector. One sector consists of blocks. What are these blocks? OS data blocks. Operating system data blocks. Okay. Some blocks may be filled and some blocks may be empty. Alright. Now, this block contains bits of data. Block contains bits of data. Now, the collection of operating system blocks are known as the Oracle blocks. Okay? Whatever the data that we are going to store in the database will be in the form of blocks. The blocks are the smallest storage units, tiniest storage units. Okay? Now, the Oracle database, Oracle recommends to have a data Oracle block size according to your requirements. Okay? So, if you are unsure that what block size that you can choose, starting from 2K, 2 kilobytes, 4 kilobytes, 8 kilobytes, 16 kilobytes, 32 and 64. So how many? 2K, 4K, 8K, 16K, 32K, and 64. There are 64 types. Any of these you can choose, depending upon your requirements. However, Oracle recommends, if you are unsure which block size would you choose, then Oracle recommends to have an 8K. 8K is a block size. The default, whenever you install the Oracle database, the default block size would be 8 KB. The block size of each block size would be 8 KB. Now, hard disk, what you see here is this one is a spindle. Okay, this is a cylinder. It's called a spindle, which will rotate this piece. Okay, and this is the magnetic layer on which the data will be stored. And this is the arm. Okay, and also it is called actuator. Actuator. A-C-T-U-T-O-R. Actuator. Right? This will move to and fro like this. It will move very fast. And that's why it is moving. Rotation per minute. This will rotate very, very fast. Okay? So, so the computers or a server may have more than one hard disk. More than one hard disk. One single hard disk can have more than one operating system. Okay? We can install and we can boot one at a time. We can use one operating system at a time.
One computer does not go ahead. So is that something only internal hard disk?
Yes. I'm talking about internal hard disk. Internal hard disk. More than two also. See, the hard disk will be connected to a SATA port. If you have opened the cabinet of this computer, okay, you will see. Maybe I'll show some of the time. Okay, there will be a port for SATA. SATA means that the hard disk type is also SATA. The SATA technology, serial 88. The SATA is serial 88. So, depending upon the motherboard that you have, that decides how many hard disks that you can have. Alright? So you can have more than 2 or more than 3 or 4 hard disks also. Now what you can do is, you can club those number of hard disks and you can create a group. You can create a group if you want. And you can also have more than one operating system on one single hard disk. But you can do one at a time. Alright. Now, the thing is, now we are talking about saving our data. Okay, the data on the hard disk. How we will save in case of disaster. In case of disaster. Okay, if any mechanical failure, if any technical failure in the hard disk, how we will save your data. So you will add another disk and you can manually copy whatever the data in the hard disk 1 copy to hard disk 2. That's a manual copy. Every time you have to spend some time copying the data. And it's very, very tedious and tiresome job for copying the data from one hard disk to another system. Now, to overcome this, fault, to overcome this fault, a technology called RAID. RAID. RAID is this array of independent. Okay, RAID. RAID automates the copying. RAID automates copying. From one disk to the another disk, data will be copied automatically. Okay? So, the RAID comes along with the operating system. Right? And RAID is also used in SAN, NAS, and DAS. What are these? These are nothing but a collection of a device just like a server, okay, which will have multiple disks. And as you wrote already, the SAN is also known as JBOD, just a bunch of disks. Okay? Alright. So, the automatic method of copying the data is known as a RAID. Okay, there are different ways which we can copy the data. There are different types like RAID 0, RAID 1, RAID 0 plus 1, RAID 1 plus 0, RAID 5, etc. Okay. RAID 0 means typing and RAID 1 means mirroring. It means I want to copy the data from one disk to another disk. It's called mirroring. And I want to copy some amount of data in one disk and some amount of data in another disk. What do I achieve with copying the data from one disk to another? I achieve the data redundancy. I will be saved from the data loss. In case of mirroring, I will be saving the console data load. If one disk is crashed, I have another disk where I have all the data. But in the mirroring technology, in the RAID 1, the performance will be slow. The performance will be slow. Whereas in striping is like, one job is done by two people. Half of the job is done by the one person, and half of the job is done by the other person. So you get the good performance. The copying can be finished within a couple of minutes. You get the performance, but there is no data security. In the RAID 0, there is no data security. If one of them is failed, you lost all the data. Okay. To overcome this force, the performance, to achieve the performance as well as to achieve the data redundancy, we have nested RAID. Nested, N-E-S-T-E-D. 0 plus 1, RAID 0 plus 1. You see, have you written this point? So RAID 0 plus 1 is known as a nested RAID. Nested RAID. This is a combination of RAID 0 and RAID 1. Combination of RAID 0 and RAID 1. Now we have another category, RAID 5. In all of these RAIDs, we need at least two bits. For RAID 0 and RAID 1, okay, we need two bits. For the nested RAID 0 plus 1, 1 plus 0 and RAID 5, we need a minimum of 3 bits. Minimum of 2 bits. Alright. So what will happen is, this is, say for example, this is this one. This is this two. Okay, in the information of the disk 1 and disk 2 will be written in the disk 3. Okay, if any of the disk is crashed, then this disk will know which disk has what data. This word. We'll be learning more about the storage technology in time. As you will see, we are following this syllabus. Hardware is finished. The computer hardware is finished. We are using the computer is working. Maybe I will maybe we'll do the storage technology today. Yes.